fine, but it's a long day today.
I get you. Lana relayed me a message. It's this. She said, "You're the best Cal teacher ever."
She's been my Cal student for 3 classes now.
She already knows the truth, though. Wait, when's the quiz?
To be announced.
To be announced? So not today, right?
Yeah,
Sure.
and not next class. I'll always warn you.
Thank you.
There is an assignment I'm asking you to turn in if you want to do that before everybody else gets here.
Oh yeah. I was stressing because I thought I had like 4 of them I didn't complete, but I actually just didn't complete like half of one.
What are you turning?
It's under bell work.
Number 7.
Okay.
Excuse me. Oh yeah, we got a quiz. Is the quiz on Friday?
It won't be next class. We've got a little bit more to do.
And we always have like just a day of review, right?
Sorry?
We always have like a day of review, right?
Well, maybe not a full period, but I will always warn you before the quiz.
Okay.
Can you sign this real quick, please?
Sure. Well, I have to look this up before I can sign, so I'll give it back to you.
Okay, sensitive.
Okay, I need your classwork / homework from last time. That was assignment 7. So make sure your name is on that. And come turn it in the box here to start a class, please. Assignment number 7. It's written under bell work. And then you need a blank piece of paper for assignment 8.
Did Cam switch classes?
Huh?
Did Cam switch classes?
No, he's just out today.
Gotcha.
Sorry to disappoint you.
He wasn't here last time either.
It says school business.
Pretty cool.
And Ben has code. Okay, so you will need a blank piece of paper for number 6 today. I'm sorry, for number 8. And I'm going to tell you what we're going to do there. And you'll need to get number 6 out of your binder. Okay, last call. Any other assignment number 7s? Okay. All right, on your blank piece of paper, number 8, if you would go ahead and number it as number 8. Okay, what I want us to do on number 8, so of course throughout the year we need to do some A/B review. And so I've been trying to pay attention to what you guys have said and my first period class has said about things that they just feel rusty on. So we're going to review 2 things on this, number 8, and I will ask you to turn this in next class as participation points, so make sure you're getting all of the same stuff down that I am. But really what I want to do is I want us at the top to work the 6 trig derivatives. So we're going to review that, but we're also going to review quotient rule at the same time. So these first 2 we're not going to go dive deep into. These 2 you need to have memorized or we've got bigger problems, which would be the derivative of sine and cosine. Derivative of sine is,
Cosine.
and the derivative of cosine is,
Minus sine.
good. Okay, so those 2, we've got to have working knowledge of those to move forward. Okay, but in an ideal world, you still have the other 4 memorized. But even if you have them memorized, I want you to follow along with us here. So, tangent, cotangent, and then secant and cosecant. So as we work these, I would like you to come back up here and then fill them in at the top of your page. That way we have a spot in your binder where the 6 trig derivatives are. So again, ideal, you just memorize them, it's quicker. But I have mentioned, and I may have even done one for you the other class, that you should be able to figure out these derivatives on the spot if you know a few trig identities. So in our middle section here, I want there to be a middle section. We're going to write down the trig identities that we need to remember as they come up. So first up, we're going to do tangent. We're going to take the derivative of tangent. But we need to rewrite this in a way, actually before we do trig stuff, we're going to practice doing the quotient rule on each of these. So quotient rule, there's no way around that one, you have to memorize it. If you take the derivative of, well first off, how do you know if something is the quotient rule or not?
As division.
Quotient just means division. So if you were trying to take the derivative of u divided by v, u divided by v, what does the quotient rule tell us that derivative is?
V prime
Okay, derivative of the top with the bottom left alone, and then what else?
minus u v prime
Good?
over v squared.
Very good. So either memorize this or memorize the process. Now again, I know you learned this in AB. Again, just based on, I think it was more my first period than y'all, but this was something that several of them felt kind of rusty on, the quotient rule. So we are going to apply the quotient rule to tangent, but tangent is not a quotient yet. So we need to remember that tangent can be rewritten as what over what?
Sine over cosine.
Okay, sine over cosine. That is certainly one of the trig identities they expect us to know. So let's leave a little bit more space for this second section so we can add some more trig stuff as it comes up, and then we'll make a third section. Third section is where we'll do our work here. So question number 3. I want us to figure out what's the derivative of tangent. So since tangent is the same thing as, let's just go ahead and write it this way. It's the same thing as sine divided by cosine. If we know the quotient rule, we can get pretty close to the derivative of tangent after just a minute. So, quotient rule, what you just told me, take the derivative of the numerator times the denominator left alone minus the derivative of the denominator with the numerator left alone, all over the denominator squared. Is everybody okay with where this stuff's coming from? Okay, so cosine times cosine is cosine squared. Sine times sine is sine squared. And so we need that's another trig thing. What is this stuff equal to?
1.
Good. That's the first and most important of the Pythagorean identities. So let's add that to section 2, just in case that's one you have forgotten. Sine squared x plus cosine squared x equals 1. Sine squared of any angle plus cosine squared of the same angle has to be 1. Okay, and we need one more thing for this. There's one more trig rule. What is 1 over cosine equal to?
Secant.
Okay, so add that to the middle section. That's a trig thing that we have to have memorized. So if 1 over cosine is secant, then 1 over cosine squared is going to be, very good, secant squared. So the derivative of tangent is secant squared. So again, I would prefer you just to memorize this, but I also am wanting to show you that you could figure up what the derivative of tangent is in the moment. So add our answer up to the top. Oops, sorry, that's my work from my other class. The derivative of tangent is secant squared x. Now, shouldn't I put a plus c here? I thought we always have to put plus c. When do I do plus c? Good, integrating but not derivatives, right? Okay, next up is cotangent. So to work cotangent, we need to think of it as a fraction. What is cotangent the same thing as?
Cosine over sine.
Okay, you could say 1 over tangent, which I guess if you know the derivative of tangent, you can go that route. But let's go with cosine over sine. That way we only have to know sine and cosine derivatives. So I expect you to add this to the second section. Even if you remember it, we're making a reference here. We're making a document that could help us in the future. And then for question 4, this is what we're going to do. We're going to find the derivative of cotangent x by thinking of that as the derivative of cosine over sine. Now, by the way, again, I'm doing it this way because I think this just connects a lot of dots. It seemed like y'all needed quotient rule practice. It seemed like you didn't remember some of the trig identities, and we're just doing a 2-for-1. But just a heads up, those of you that keep on with your math education, if you continue on and you eventually go and get a math degree, then there's a good chance at some point you're going to take a class called Advanced Calculus. So Cal 1, Cal 2 is Cal A, B, and BC. So assuming you pass this BC or this AP exam for A, B, and BC, that's Cal 1, Cal 2 credit. Cal 3 is the same stuff but in 3 dimensions. Then there's a class called Differential Equations, which is kind of like Cal 4. It's a little bit different. But then some people choose to do Advanced Calculus. And it's not that you learn more calculus in Advanced Calculus, but you have to prove the calculus that you've used. So you don't use the mean value theorem, you prove the mean value theorem. You don't just memorize the derivative of cotangent, you have to derive the derivative of cotangent. So stuff like that this would be like some of the easier stuff you would do in that class, but you'd have to prove everything that you learned in AB. Okay, so let's go on. Just a note there. I never took Advanced Calculus, by the way. Like when you get a degree, you get to pick and choose, so you don't have to take certain classes. You get to pick. I did Abstract Algebra instead of Advanced Calculus. But okay, so let's apply the difference or the quotient rule here. So derivative of the top times the bottom left alone minus the derivative of the bottom with the top left alone, all over the denominator squared. So this looks like negative sine squared x minus cosine squared x over sine squared x. Now, I know a few of you are going to be tempted to try to cancel these signs, but remember you can't cancel terms. You can't let these cancel because then you're ignoring that cosine squared is also over sine squared. So what else could I do to this numerator? Okay, or factor it out. I don't want to multiply by -1 because I don't want it to go away, but I can factor it out as a GCF. What is sine squared plus cosine squared?
1.
Okay, we already wrote that above, so we don't need to do that again. Okay, and then it looks like we need to update one more thing for this one in our second section. 1 over sine is the same thing as what?
Cosecant.
Okay, so if 1 over sine is cosecant, 1 over sine squared would be cosecant squared, and it's negative. Okay, so copy that down, and then go ahead and put that at the top of your page. This is why the derivative of cotangent is negative cosecant squared. Okay, I'm going to ask more out of you on question 5, and then on question 6, I will ask you to try that one from beginning to end. All right, number 5, looks like we're trying to figure out the derivative of secant. Okay, do we have that up here? Yeah, we do. Secant is the same thing as what over what? Okay, secant's the same as 1 over cosine. So if you remember that trig identity, which you need to know this for other stuff anyway, now it's the derivative of something divided by something, so we can apply the quotient rule that we need to know anyway. Derivative of the derivative of the numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone all over the denominator squared. Now, of course, 0 times anything goes to 0. So right now, I am at sine x over cosine squared x. Now, even though this is true, this is not how we memorize it. If I ask you in a couple weeks, what's the derivative of secant, I'm not expecting you to say sine over cosine squared. So we still need to rearrange this in some way. In fact, those of you that did pre-cal, if you remember first semester pre-cal, do you remember that you had to do trig proofs where you like try to make this side look like this side by doing algebra and stuff? So the purpose of that was so that you had some experience being creative in how to rewrite this. So instead of calling it this, how could I maybe rewrite that?
You could do tangent.
Okay, wait, where's tangent coming from?
Wait, no, never mind.
No, tangent's not wrong, but where's...
Yeah, the sine over cosine.
Okay, so we could put sine over one of the cosines, and that would still leave another cosine though, right?
Yeah.
So what is this? What is 1 over cosine equal to?
Secant.
And sine over cosine?
Tangent.
So there is the derivative of secant. The derivative of secant x is secant x tangent x. Now, of course, if it wasn't just an x, you would also have to factor in chain rule, but chain rule is a constant. So finish copying that down, and then jot that answer at the top of your page. Secant is secant x tangent x. Okay, and then last one, again, I want you to try this one from beginning to end, but just to make sure that we're all start off correctly. For cosecant, we should change cosecant into 1 over sine. So make sure you change it over to 1 over sine. So use the quotient rule, see some of those trig identities that you can plug in, and then see if you can figure out what the derivative of cosecant is. See if it looks familiar once you have it in front of you. Anybody still working? Yep. Okay. It's fine. I'm just checking. Okay, so if you slowed down or got stuck, let's help you get unstuck. All right, so again, changing this to this, we don't need to know that often, but occasionally. Applying the quotient rule is a very common thing for calculus. It's not just AB, some of that carries over to BC. So derivative of the numerator times the denominator left alone, although that doesn't really matter, minus the numerator left alone times the derivative of the denominator, and then over the denominator squared. The denominator squared is what y'all forget the most on FRQs. Multiple choice, you never forget it because you see those. So you've got a negative cosine x over a sine squared x. Now this doesn't look like how anybody memorizes it, so technically this is true, but how can we split this up?
Negative cosine over sine times 1 over sine.
Okay, so it's like you're unmultiplying fractions, and that's a good choice because this ends up being,
Negative cotangent.
and this ends up being
Cosecant.
cosecant. Now you don't have to put them in that order, but the order of multiplication doesn't matter anyway. So negative, the derivative of cosecant x is negative cosecant x cotangent x. So it's not that much work to do. Worst case, by hand. But the one last thing I want to point out about this, and again, I will give you a couple participation points and pick this up next time. But if you were in my AB class last year, I already pointed this out to you because this is consistent with a lot of calculus stuff. But there's something that 3 of these have in common and 3 of these don't have in common that helps you memorize them.
Starts with C, it's from
Right, if you're taking the derivative of something that starts with C, it becomes negative, and anything that you're taking the derivative of that does not start with C is positive. So obviously that's not enough to get the whole thing, but it does help you remember the minus signs. Okay, so what you should have gotten out of this is these are the 6 things that you're still on the hook for memorizing. There's a good chance I might put 1 or 2 of those on our first big quiz when we get there. I still don't have the exact date of that. It's probably about a week and a half away. I will warn you 2 classes before it comes, so don't worry about it yet. But I might put 1 or 2 of those on there. Also, what would be fair game is the quotient rule. Should remember quotient rule from last year, but if you don't, you might practice it, doing it a few times. I will not make you derive anything on our quiz, but deriving it this way is kind of a backup. If you're not 100% sure this is the correct derivative, you can figure it out in the moment. So, everybody okay with that? Okay. Then the other thing, so where you should be spending the bulk of your time today is number 6. This is one we looked at last class. So let me speak on it for 30 seconds, and then I will let you work and see how it goes and see what kind of problems you come up with. So the first BC exclusive topic we did was partial fractions. So we did that one day, and then you practiced it more last class and for homework. That's what I'm going to be grading here in just a minute. The second BC exclusive topic was this integration by parts. So you need to, 1, know when to use it. It's when you're integrating something times something. 2, you need to memorize this formula. If you're integrating u v prime, it will integrate as u times v. minus integrating v u prime. And even though that sounds pretty difficult, for the most part, if you can figure out what u is, you can take the derivative to get u prime. Everything else is v prime. You can integrate to get v. And if you have these four things, you just plug them in the way the formula says, and you have to do one more integration because the formula has an integration piece in there. Sometimes though, and I will warn you on a few of these questions, sometimes this part that I will highlight is still asking you to integrate something times something, and it's not one we memorize and it's not one we do use substitution on. So if you're trying to integrate something times something, you might have to use integration by parts within an integration by parts problem. You might even have to do integration by parts 3 times in a single question. And in those instances, you should really try to use this table method. So if I was you, I would take a minute to look at that, make sure that you see why we picked u and v prime for what they are. It's typed up here. Look at how we set up this table and how it formulated our answer. And then last class you only did 2 of these. I did one for you as an extra example, but you should have already worked number 2 and got your questions answered from it with the formula, and you should have done number 8 with the table method, because that's what I recommended. So I would like you to finish this up and get all your questions answered. So if you worked ahead last class, then you've got a little bit less to do. But if you did the bare minimum, I still think you've got time to end class finish that up and get your questions answered and check your answers. So hopefully you won't have any homework. But if you don't finish this number 6 and feel like you've got this skill under your belt, under homework, I will ask you to finish it and check your answers with the class website. So as you guys work through these, I did post the solutions up already. So again, you need to check your answers at some point. If I was you, I would check them as I worked so that I could make corrections and not have to redo a bunch of work. But I guess that is optional. So that is our plan for class the rest of the day. I'm going to grade these homeworks, pass the homeworks back to you, and then I'll be available to help out. Now I will say also, even though the answers are online, some of the questions first period asked me, you guys know that your work in this can be 6 or 7 steps. If you're jumping around all over the place and your work's hard to read, I probably can't look at it and figure out how to help you. You need to make sure I can read your work very legibly if you want some help on it. So, not trying to be rude, but I just not going to get a headache trying to read through 10 questions when it's all scrambled up and hard to decipher. So. All right, any questions? Okay. Again, now since I'm not working on the board, you guys are welcome to work together. Maybe your neighbor does the checking of the answers, you don't. Maybe next time you alternate, that's fine. You want to help each other, that's fine. Unless we come up with a common question, I need to work on the board. I want you guys to work together. So feel free to work with your table partner as you have questions. And I'll be available in a few minutes.
Wait, I got positive. Remember, I didn't get negative next week. I got positive next week.
You guys done? You checked your answers too? Okay. What do you do that?
Did you get it again?
That's innovation.
So what'd you get? Oh, let's just check this. Okay, what'd you get for
So how long did you
The Tucson rags.
No,
I didn't know whether to use the other one.
I usually just start with the other one, and then when you set up the minus, integrate, blah, blah, blah.
You have to do it again.
Yeah, if it looks like it's gonna be integration by parts the second time, that's when I usually ditch that and just do the table. But you should probably practice Sylvia and Josie came by yesterday.
They did?
Yeah, they said they feel bad for you being stuck with me every time.
No, I didn't.
No, they didn't.
What'd you get? 4 after
They're jealous.
490 you did grid.
Oh.
9 over 25 you did 9 plus 1.
Integrating two side effects.
I think it's.
Then just do F next.
I'm gonna do it again.
Wait, no, it's just, so it's 2 x.
Jax goes up.
Is it, like,
Oh, you're right.
yeah, I think
You get to
Okay, then 6 becomes.
Take the 2 out. Makes it constant.
that's what you
And
should.
then
Yeah,
just-
I thought it
Oh.
was.
Oh, I see.
Negative X squared plus minus plus 2. And then this is plus minus plus 2x minus plus 2. Did they do the table?
Okay, I'm sorry, I've got one more interruption for you. And I think I was putting this on our agenda the first few classes maybe, and then I kind of forgot because things have been going on. So, you are welcome, it's completely optional, but you're welcome to check out a textbook. I've got tons of calculus textbooks back there. But realistically, we'll probably only use the book 5 or 10 times like we did in AB. So you really shouldn't need to check out a book. But if you would feel better having the book at home, if your parents expect you to have a book at home, I can check you one out. So just let me know today that that is you. Additionally, I've got a set of 10 calculators up here that you're welcome to borrow while you're in class. But for AP math students, you can also check out a calculator all year long that you can take home. So it gets checked out to you just like a textbook does. You still have to bring it back at the end of the year. If you lose it or it gets damaged, you have to pay for it. It's like 140 bucks or something. But does anybody know that they would like to check out a calculator for the year to leave at home? Okay, if you change your mind, I've got a bunch of them in here, so I can do that for you at any time.
Does that mean we won't have book homework this year?
5 to 10 times. But when we need it, I'll either copy the pages for you or you can just Well, I guess you can't take pictures. I'll just copy the pages for you when we need them, so.
Oh, I didn't
Like share PDF.
Yeah, I could share the PDF. I have a PDF of it. Or, like, if we're working on page 77, I might just print page 77, 78, and then the answers in the back and just give it to you as a worksheet that way. Y'all don't have to keep up with an extra book. But some people like to have the book, so I just wanted y'all to have that option. Okay, rest of the class is to finish up this number 6 from last time. Make sure you're checking your answers on the website. And when you're stuck, work with your neighbor or ask me for help. That's the rest of class.
So I know I have to do
Oh yeah, so no, it is supposed to.
Use tables.
white marks again. So
Yeah.
how do I just like plug that in here? Like the U or U prime V?
Yeah, so you almost need to work this like as a separate question out to the side. And your answer to that question will, you can tack it on right there.
So I do the UV minus U minus inverse V and then I just add this.
But
Okay.
I will tell you that if I see that I'm gonna have to do integration by parts the second time, I usually just do the table myself. Because the problem is, doing it twice isn't impossible. You can see it's gonna get kind of complicated to keep up with it. But then there's still a chance you might have to do it a third time. And
Yeah, you're right.
I just knows out of that.
I was just wondering. Yeah, I was thinking the same kind of thing.
Okay, I got 2. I wrote it backwards. Okay, yeah.
They won't.
So you only did it on 8? 3 and 8.
Convinced you got every answer right. Or wait.
Is that actually
I don't know about yours. Mine
So, what is B? What is B for?
yours is right.
y'all both just spoke up? You just
You got it. What year is 9 come? What year is 9 come from?
what?
You need a chain rule. Yeah, you need chain rule. Because 9 barrel 1/3 is multiplied by 1/3. Balance it when you're integrated.
I used to table it.
I got 9 8.
I'll go back to that later.
Wait, so how do you even know when you use table and when you use
I used it.
Wait, it's number 9.
I think he said you always just try the normal one.
Okay, thank you. Well, it's the. It's not long B, that's.
Just this, right? Or no?
it's a 4 now.
It's a 4 then. Oh. Oh, chain rule. Okay.
I got 4. No, I have to do it for 4. Roger, what'd you get for 4? Yeah, that's what I did. You know why? Because that's changed. You got 13, 18 for 9.
No, I missed.
That would be easier.
Oh, no. 6 natural minus 1.
Ooh. What do you do when there's? I completely forgot. What do you do when there's like some other than X? Like when you're putting e to the power of something besides X.
Well, what are you trying to do? Derivatives or integrals?
Integrals.
Okay, well then you just need to make sure you undo chain rule. So if you have e to the 3x plus 1, what can you take the derivative of to get e to something? What's the derivative of e to the x? E to the x. So the derivative of e to the 3x plus 1 is still going to be e to the 3x plus 1, but because the chain rule is going to be times 3. So if you're trying to take derivative, you're going this way.
Oh, I see.
If you're trying to integrate, you might need to multiply by a third if you want that to be a 1.
Okay.
But just take the derivative of whatever you write down and check it that way.
Are you in number 6
What was your U for?
So the third. So you're taking a third of the integral?
You're trying to integrate this? You're trying to integrate this?
Oh.
Okay.
Oh wait, no. Sorry. No. I was deriving that. Sorry.
Okay.
So the derivative would have the 3.
The derivative would create a 3, yes.
Yeah.
Yeah.
And so.
So if you're integrating it, you need to multiply it by a third to cancel out the 3, because there's not a 3 up front.
Okay, so. Yeah. So would I put that as like a constant outside of like when I make the integral with the u or u?
You can. Most of the time people pull out the constant.
On number 6, why do we have to use this? Integral parts. Why can't we just?
Okay, well how do you integrate natural log? That's true. Probably don't memorize that. It's something.
What?
So I guess we could make you memorize that, but you don't use it very often. So.
Like integrating natural law.
Or maybe I did something wrong.
No, I think the answer is there. Yeah.
Can you
You
check?
can't integrate that. Well, you don't have it memorized. Derivatives won't ever, but integrated natural like isn't. So you gotta split up u and the b primes and you can figure it out.
Oh, you're on 6.
Yeah.
Wait.
I used
Oh, yeah.
I didn't use
It's, yeah. B prime is X. No.
For what? Individual parts. In this.
What do they even happen?
Can I watch a video?
When you watch my video,
Should I watch a video?
You're done with this?
Yes. I
You
checked
checked
it.
your answers?
Yes, sir.
You're all good with it?
Yeah.
Any of these I can put on your test next class and you'll be good?
Probably. Most likely.
Okay, do your video and then,
Because I need to use my headphones.
not if they're wireless, you can't use wireless.
Seriously?
You
Like even if I forget my wired headphones?
got, no phones, no wireless earbuds,
What if
no
it's-
smartwatch.
What if it's about Oiler?
Mm-mm.
No. Okay.
Did you just move into the district?
No.
Oh, they didn't have a picture for you. You got a picture in there, dude?
Yeah, I took it last.
Oh, yeah. On nine.
I took it
I
one time.
used to have the 6, but I thought the
What's that?
second person was
Grade book has faces. So I printed out the faces of people that I didn't know yet, so I could learn names faster.
Oh.
But his picture was there. So usually that means somebody like just moved to the district and they had to take a
Like,
picture.
how recent is just?
Oh, I don't know.
I was here last year, but you,
Oh,
No,
yeah,
I don't
that's
know.
probably it.
Are you transfer?
You had an ID last year with a picture on it?
yeah.
Somebody must have messed up and didn't put it in grade book.
So mysterious.
But yes, I think y'all are crazy if you don't buy a pair of cheap
Oh, absolutely.
wired headsets.
No, I just left mine at home.
Leave them in your backpack. Sorry, it's not my rule.
On fives.
So have you decided the date of the test or not?
That's it. I still want to do improper integrals and we need to do a review.
Oh, I see.
I just don't know with improper integrals if we'll need to spend a day or two. So, and then I'll probably throw in 1 day of AB review, and then we can have our first quiz.
You should teach Cal 3, so I can have you for a third year.
Cal what?
Cal 3.
We don't offer Cal 3.
You should.
I definitely don't remember Cal 3. I just remember it was easier than Cal 1 and Cal 2.
It's in 3D, right?
So it's like the same formulas, but then they add a little part to it to make it work in 3 dimensions. You do X, Y's, and Z's.
That's awesome.
Multivariable. Actually, that red calculus book up there is the calculus book I used in college.
Which ones?
The red one.
There's a lot of red ones.
Oh,
They used it for Cal 1, 2, and 3.
So the X and Y
It was like a $300 book.
isn't like
Oh,
something you
300?
so that's
And people who dropped Cal 1, like they weren't getting the grades they wanted, so they dropped it, then their book was worthless because it was the old one, so that nobody would even buy it. They had to buy another $300 book.
That's great.
Yeah.
right now the 1/5 because it's a constant and then
Because you have bounds,
X to the 5th.
1 big squared, so when you plug those in, that's where the rest of them. Now, again, it's not wrong to keep up with plus c, it's just that if you do a plus c for this, and then a minus plus c, they're gonna cancel out anyway.
Yeah, right there. So take that 1/5 out, so that one has the X's, and then send 1/x times is that
Oh. So it's
Sorry,
like
I don't know
the
if I'm like, I'm a little slow today because I had 0 hour, so.
this X by the
UV, okay,
it's not. It's like
minus integrating
I don't know how to explain that,
d
but
prime. You really should put a dx here. That's
Yeah,
what,
yeah.
this dx is where this dx is.
Right.
So just like you pulled this 1/3 out.
I pulled out a 3/4.
Okay, wait. So right here, I think this is where it is. When you pick, to start the problem, you need to pick out u and u prime.
Yeah.
U is something that you can take the derivative easily, like for
Yeah.
everything else is d prime.
Yeah.
So there's no 1/3 here
Well, I
until
just-
after you integrate it.
Yeah.
So 1/3 goes with d,
Oh,
not with
d.
d prime.
Yeah.
It's not going to happen until you integrate it.
No, it's just like you can't.
So maybe that's what's missing. Okay, over here.
Yeah, that's just like cool.
And like a lot of these handouts, the last few questions are real AP questions from the past. So it gives you an idea of how difficult integration by part questions they expect you to do.
So this would be
Yeah. I'm just trying to look at them, I don't remember. I like, this one is kind of weird. That one's pretty straightforward, I guess.
I'm also like, I would like set it up like that, right? This would be like 4 times 1/3. Be like 4 times that. Right.
Okay, so here's your U times, UV, all the way through there, minus integrating V. Where's your 1/3? Where's your 1/3 there?
Oh.
You're integrating V, U prime.
Yeah. So I'm just.
I don't know why this 3/4 is here. I don't know where that's coming from.
U sub.
But you didn't, so you did this integration or not?
X to the 10.
Well, I'm stuck on it.
I know, but you're saying you did U sub, which would mean the integration symbol would be going away.
Yeah.
Oh,
But, so it's one or the other. Either you did it or you didn't. See, I just disagree with your 3/4. I don't know where that's coming from. So you need to integrate this, so the 4 can come out front.
Yeah. Oh, yeah.
Don't worry about that later. I'm okay with the constant coming out. Then when you integrate this stuff, it's gonna create a 1/3, there you go. But now you need to finish the integration. So you need to the 3x plus 1.
Okay. So just do 4 thirds, we do 3x.
That part. And then you can check. Whatever you write down here, take your derivative and just go back to there. If it's not the same, then you gotta keep working on it.
I'm extremely slow today.
Okay, but
I just, yeah.
you're gonna be faster if you slow down and work a little more carefully than it is to redo it a couple times.
I got an issue with that.
So you integrate this. And then, well, then it would be times 1. So it would be 1 times expansive. This one? Or integrate x to the 4. Raise the power and then divide by it. X to the 5. And then all that stuff, so. And then it's just balance.
Oh, and then just the value. Just like the value, plug in 0.
Yeah.
Wait, so why did you do this thing here?
You plug in your
Because
upper
you
bound.
can't.
But like, that doesn't make sense. It has zero impact.
Yeah.
15 minus. No, you don't do that because and then use 19
I
So what did you do for the year for such?
I did. You did one X.
Why do people
You did a 7?
Yeah. I did vegetable X.
Oh, wasn't it mistake check that was
Go to, can you just put on the 7?
Okay, you guys still got about 30 minutes of class, so still plenty of time.
Yeah, that's what we did. Yeah, but I guess it's wrong in traffic because they would say on the side. It's like for this problem, like
I thought it'd be good if they checked because it was neutral.
yeah. I don't know, it's wrong in traffic. Oh, I figured out why. Well, okay, not really figured out, but I think I figured it out. Remember the question from the quiz? It's like -2 and neutral and yeah. Because like there's no potential difference between the two. The arbitrary difference or size. Yeah. Because there's a difference.
So you can do that. You should use it.
Did you just do
that.
So you really don't. Like you didn't think about it. I didn't think we could rerun it again. Like so
didn't check it, so we like,
Sorry.
you guys did link that first and then did it again. Yeah. We didn't do it this week because then we realized, oh my god, they're also cheaper to charge.
Yeah.
Because like, you don't even know how much you're like, it's not the same how much
I don't think that's a
Wait, did you guys do
Should I go talk to Mr. Faulkner?
yeah.
When you get the keys, yeah.
Kinda.
When the pass is
Like,
back,
guys
you can.
go to the
If he's not busy teaching,
Oh.
don't interrupt his class.
Or like you
Oh.
move the balls immediately. Yeah, we didn't do that. We rubbed and then changed. Yeah, I think you're gonna see that one. I was thinking that first, but that was not. Bouncy balls. We should do this here, this.
Why does he cite it in June?
You don't know?
No, it's over the.
No, not that, so the book.
I just didn't write down what he got for six, not six.
It's the same formula.
Yeah.
Oh, really? I haven't got that.
Well, Alex,
Kevin.
Oh.
You didn't take it on school.
Yeah, and two.
Where is negative six from the?
Yeah, reading, but.
Wait, why did you guys say it's
It tells you.
Oh.
No, I told you.
Oh.
It tells you on there.
Yeah, that
On
explains.
what? On what?
Master mistress. Oh,
For ELF?
no.
Oh.
For AP classrooms, right? Okay, what? It's just two classes, and there's a check answer bubbles.
Oh shit. Crap.
What would be on the table if it go over that.
But that's the original.
It's after double consideration.
It's about 6 or less. So basically, I missed one. But I feel like that
I went on the internet and just yeah.
the first one that works well.
Yeah. You left.
Wait, wait, so like
What was this
so you use two more than you have here.
the one that makes no sense.
Because you
Oh,
go
it
over
makes sense. The
them.
questions are just weird. It was just talking about
You
how people
derive all
who
of
did actually
you integrate
Yeah.
I wouldn't be surprised.
Wait, derive or
Is that right?
Isn't the whole thing contradictory? Like, because he's like criticizing.
It's because like they're the two there and
You do.
yeah.
Wait, what's the derivative of
Yeah, it's
cosine? Sine is negative. Derivative of solid is negative cosine. You integrate physics. Yeah, you integrate. Wait, no.
It's just integrating using the
Wait, what? There's no history.
I don't think you used to do this either.
There's just no history for 6 weeks.
Yep.
So I had their F and G terms right there, which you put as U and V terms, and I have those right there. But then they're being evaluated from 1 to 2, and I don't understand. That's kind of where I'm losing this. Like, why are they evaluating all of this?
Okay, well, you have to remember that the original question, you're supposed to be evaluating from 1 to 2.
Right,
This
right.
formula, U times V, blah, 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 it's just telling you how to integrate this. But you still have to either throw on a plus C or evaluate from 1 to 2.
Right.
So since they've integrated that part, they put 1 to 2 to remind themselves they still need to evaluate from 1 to 2.
ABC.
And then over here, they still need to integrate from 1 to 2.
And I get that. I get why you have to do that, because there is an actual
Yeah.
integral symbol, but there's no integral symbol on the UV.
That's true, but when you evaluate this, if there was no bounds, you would need a plus C here. But because there's bounds, we can still plug numbers into those.
Okay.
So the formula is just telling you how to set it up. You still have to evaluate from 1 to 2 on the whole thing. Not just this second half that shows you the integration. It's the whole thing needs to be
Right,
integrated.
right. Okay.
Even the U times the V.
All right. Thank you.
And then, yeah, so is that, so then there's
I think I was thinking like a 2360 or a 21. Almost there, yeah.
Because in time Q,
You've taken it twice?
that would make you,
How many times have you taken it? Yeah.
So you take
it's
the,
x squared.
so you, yeah, it's 1 half, it's not 2 sine. It's 1 half sine to it.
What is changing? Just everything else.
And then there's just one more chain rule when you integrate, right? So it turns into one flow. Yeah, because mine is the integration that when you integrate it, it becomes integrated.
What do you mean that's not bad? That's
I was in one app. That was it.
Use the rule of signing of flags.
So when you integrate this,
Yeah, we integrate this. The arcade times 2, but it's actually times a half. Because you have to time the derivative of 2
you just try to get that out. Yeah, because there'd be 4x. Yeah.
One of us will probably have to pay something. Yeah, and then 4 people play and then 1 person.
But how do you use it? Like what is the plan?
When does it
Yeah.
Oh, it's your topic to learn? But
So
aren't there
you
so
can get
many
better.
like
You have more
fast
fish. Every time it's on
No, but like for example, like 7%, what's the most studied? Really or not? What? I forgot what it was. Okay, well, I actually didn't know that. I remember doing that. What is this called? Wait, 39 million is about 1 million. one, oh, sorry, one.
But we're like out of the season, but like, don't know why we do that.
What's that 1 billion? Oh, wait, sorry. It's 1 billion meters. And then how many do we have? Oh, yeah, the 1 billion. Okay, so
You have to sign up also.
How about you?
do you keep the
What do you do?
I literally, that with like 5 minutes down.
You do what?
I live Say.
Yeah.
I live off Say. Which is off Holcomb. That. Yeah. None of my
Are you on the side? That helps. To the north of them? Because it makes pretty big difference.
Oh, the south.
So you're in the spaces.
I just guess?
Yeah. I live basically the bottom. Oh, okay.
Is it weighted?
So it's not like the
It's a
way
couple of
biology.
Yeah.
I'm not that
It's mainly one.
That's more
Secretary at the clock.
Oh, yeah, yeah.
No,
Always put one.
That's what I was thinking here.
It's probably like 80%.
like this week.
It was like, what is it?
Well, you can get the membership.
Oh, really? Yeah.
I love everything.
People actually write.
I go up here, sir. I go up Sunday and
It's just more
Monday.
opportunities for hours.
You're just
I am.
Joel
And asking people to
I'm
No.
I watched for 2 days in a row.
how far, stores that was. You got one of the push carts?
No.
You need to get with it.
carry it for 18 holes.
Well, it's not.
Do you guys do skate?
The creek courses? It's only 9?
You can pay 18. I'm only paying 9. Well, I actually, yeah, I just,
You need to get one of those, if you walk so much, you should get one of those push carts.
yeah, I don't really think I do. Well,
Strong man.
it's like a food book.
Yes. Yeah.
Oh, I usually have my own girlfriend. It's like,
You build it, decide it.
Oh, that sucks.
that was bad.
Oh, yeah, you
Like,
can do that.
Like a
backpack is it does sometimes.
My bag's
I'll make another. Yeah. Water.
Yeah.
How many words is
4, 5, 6.
I'll say this one.
I have barrel joggers, loggers,
You have to do your nose.
fishermen, I've lobblers, and sandwich. I have a entire 20 balls.
Yeah, very a lot.
Yeah.
My goal is to just like find more balls than I lose. So that I'm leaving
At
the
the
golf
league?
course.
At the league?
So,
So,
you know, like, is it called forward? The
Oh,
one you
yeah.
hit over,
uh-huh.
like all the trees down there.
Oh, yeah, down to the right. That's where my ball
Shoot
is
all
every
you
time.
balls. That's so
Every
much
time.
Okay, we need to finish up class here. So 3 things. One is make sure you know what the homework is. If y'all did not finish assignment 6, if you did not check your answers to assignment 6, and if you feel fairly uncomfortable with this, you should probably retry a question or two to feel pretty good about it. My first period said that they didn't feel like they needed a lot more practice with that, and y'all seem to have done a little bit better than they did, or at least you finished sooner than them. Second thing, this is one of my favorite memes that we use. Somebody explain this one to me.
Is it like the inverse of the cat eating the fish? It's the fish eating the cat.
Right, so the top one's a function, the bottom one's its inverse. So instead of the fish going in the cat's going in the fish. Like an inverse function, right? You understand the math joke there?
Yeah.
All right, and then 3, I don't have a puzzle for you today, but I've got something different. I need 2 volunteers that would like to race on solving a Rubik's Cube.
Oh, no, I'm not
Okay.
gonna win. I'm not gonna win. I'm not gonna win. Never mind.
No, it's fine. You're the first 2. Okay, up to the front of the room.
I forgot he was in this.
No, it's not blindfolded. Go to the front.
I don't think I've ever solved that.
I gotta make. I'm sorry. This one is solved. I gotta.
I'm already admitting defeat.
I don't
This
think
is-
I've
Don't worry about it. I got you.
Oh, it's
Okay.
it's the Rubik's brand one, so it's not great.
Okay, back to back. They don't open too long. So you can't see each other. See how close each other are. All right.
Yeah, I'll let you.
3 things Sumit's gonna win. Okay, thing. All right.
No,
All
don't
right.
embarrass.
Close your eyes. All right. 3, 2, 1. Go.
Do you still have the Rubik's Race?
I do. Yeah.
Oh, I like that one.
Did you get 50 the normal one?
Wait, did you get the speed cube?
You didn't invent it.
Oh, that is.
Looks like you guys might be wrong. Oh, you're pretty fast.
I haven't solved many things in a long time. Come on, Steve Bennett.
I don't know the trick was
Okay, I
Well.
got it.
All right, we got a winner. Now help him
I'm
with
looking at puzzles
his.
before class ends.
Here's the directions. If you want to come by like during advisory, you can learn how to
Yeah,
solve
I'll
it.
I don't know what's
kind of
It's just an algorithm, so if you know the steps, you can solve it. Now, the one he's got, I don't know. There's probably an algorithm for that as well. but-
Yeah.
What shape is that? Is that a dodecagon?
Huh?
What shape is that?
It's a dodecahedron.
Okay, I was thinking it was that. How do you even solve that? I don't even know how people do that.
All right, did you give up? You give up?
How fast can you solve a 3x3?
Here, wait, let me show
Uh,
you this
That one, 12 seconds. That one is not that fast.
See, I told you you'd be fine.
one. I appreciate it.
Now you can tell people you beat them out of Rubik's.
I did.
Just don't go into the details.